I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this video is for chapter 1.2, using segments and congruence. So the first thing we need to talk about is what a postulate is. You should already have that definition, but I just want to reinforce that it's a rule that is accepted without proof. So we do not need to prove this. And so the first postulate we're going to look at is postulate 1, which is the ruler postulate. And essentially what this is telling us is that if we have a line here and we have point A and we have point B, that each of those points have a coordinate value. And the ruler postulate says that that coordinate corresponds to the point. So then we can now talk about distance. And distance is the absolute value of the difference between the two coordinates. Why absolute value? Well, because distance is always positive. So if I redraw this line and I say that A is at x1 and B is at x2, then the distance AB, okay, so that's how we denote distance, is instead of putting anything above the AB, we just write the AB next to each other. The distance is going to be the absolute value of x2 minus x1. In fact, the distance, we could also say, could be the absolute value of x1 minus x2. So it doesn't matter which one you subtract, because you're going to take the absolute value. And if you think about it, if you were to actually count the space, it wouldn't matter if you counted from this way or this way, you still would have the same number of spaces. And so that's kind of what the absolute value does. I want to talk about this word between and how we use it in geometry. So if I have a line here and I have points A, B, and C on this line, between means that I have 3 collinear points. 3 collinear points means that I have 3 points that are on the same line. If this is the case, then there is a point between 2 other points. And in this case, we would say that B is between A and C, point A and point C. If I have another line here and I have point D, E, and then over here I have point F. E is not between D and F. The reason being is because they are not 3 collinear points. F is not on the same line as DE. So therefore we cannot use the word between to describe any of those points. The next postulate we're going to talk about is called the segment addition postulate. I will usually abbreviate this with SAP. The segment addition postulate says that if B is between A and C, then AB plus BC is equal to AC. Again, remember this is a postulate, so we do not have to prove that. We also know that if AB plus BC equals AC, then B must be between A and C. Remember that this right here is talking about distance, which refers to the first postulate, the ruler postulate. So if I have a segment here, okay, not a line, I'm talking about a segment, and we understand that a segment can be found on a line. So I'm going to put A here, I'm going to put B here, and I'm going to put C here. So what we're saying is that this distance plus this distance is equal to this entire distance. Makes sense? That is the segment addition postulate. So it's possible that when you're proving something or trying to explain something else, you may need to use this postulate in your explanation. The last thing I want to talk about is what is the difference between equal and congruent. Okay, first of all, let's talk about the symbols. We should know what an equal sign looks like. Congruent looks like that, where it's got the little squiggly at the top above the equal sign. We are going to use the equal sign when we're dealing with numbers. So for example, distance is a number. So if I say the distance of AB equals the distance of BC, both of those represent a number. Whereas congruent, we are going to use for different parts of geometry. Speaking of the figures. So for example, I could say that segment AB, denoted like this, is congruent to segment BC. So if they have the same length, then they are congruent. But you need to know the difference, especially in the notation. I'll just give you another example that you'll encounter very soon. If I talk about an angle, I could say that the measure of angle ABC is equal to the measure of angle CBA. I'm talking about a measure here. So maybe this is 35 degrees, then that means that this must be 35 degrees. But if I'm just talking about the angle, not the measure of it, then I would say the angle ABC is congruent to angle CBA. So just be aware of that. You'll catch on as we continue further.